Comparing linear and exponential growth. The key fact about linear growth is that linear function grows at a constant rate. That is, every time the independent variable x, say, increases by 1, right here, the linear function grows by the same amount equal to the slope. Remember, we say slope is change in y to change in x. So then if the change in x is 1, right? So your slope is the change in y, actually. So then that's what this first shape is about. And for exponentials, suppose that the growth factor is 1.2, so that the growth rate is 20%. Then every time the independent variable x increases by 1, the exponential function grows by the same multiple 1.2. If this is 1.2, 1.2 squared, 1.2 cubed, 1.2 fourth, let's say over time, 1.2 to the power fifth and so forth. So the change in x is for every one, but the change in y is a multiple of your growth factor. So problem 2 says determine which of the functions are exponential. So for A, the change in x is y, right? 3 minus 2 is 1, 2 minus 1 is 1, 0 minus 1 minus 0 is 1. So I get the 1 down. Now I'm going to look at the ratios of y's. I take first the ratio of 1200 to 1000. This is 1.2. Then 1440 to the ratio to 1200. I'll look at the consecutive points. It's 1.2. 1728 to 1200 is 1.2. So you see it's constant. It's the same value, same ratio. And so the function a, this is exponential. Let's look at b. Let's look at the ratios. I know my x is also, the difference is 1, but let's look at the ratios of the y values. 320.3 I'm sorry, 320.2 is 1.40478. Then I look at 320.2 over 308 is 1.396. And the ratio of 308 to 300, 1.0267. So they're not constant. They're not the constant ratio. So then the function is not exponential. Let's look at C. First, I want to look at the ratios. 208 to 200 and 216.32 to 208 and 224 to 97 to 216.32. So 208 over 200. Let's see. 208 over 200 is 1.04. 216.32 divided by 208 is 1.04. 224.9 divided by 216.32 is approximately 1.04. Very close, like 1.03966, so forth. So it's essentially constant. And the function is exponential of the form. Let's say q of t is equal to your initial k value c to the t. Since the values of the t do not increase by 1, you need to find the growth factor and k using the two data points. Let's take easy 0 to 100 and 10 to 08. Let's take these two values. Now I'm gonna erase this. And part A as well, and work on part C. All right. So I'm saying here my exponential q of t is constant growth factor to the power t. Okay, so I'm going to use these 2 points. So taking q 200, k c to the power 0, which is 1. So from here, k is 200. So now my exponential function becomes 200 c to the t. Next, I'm going to use the values 10 and 208. So my q is 208, 200 c to the power 10. Okay, from here, c to the power 10, if I divide both sides by, 200, this is a 1. So divide 208 by 200, 1.04. We kind of knew that. All right. So from here, c is equal to 10 to the power of 1.04, which is approximately 1.0039. So the exponential function is then q of t 200 1.0039 t. I needed to find that because the question says find the equation of the function and use it to predict the next entry to extend the table of values. So next one is every 10 it goes x, so I want to predict x equals 40. So q of 40 is equal to 200 to the power 40 will give me an approximate value of 233.69. Next question. The 1,990 population of Arizona was 3.7 million and growing at an annual rate of 1.7%. So if 1.7% is your rate, this is without the percent symbol, you divide 1.7 by 100, correct? If you divide it by 100, you're going to get 0.017, and then I'm to find the growth factor. I'm gonna add 1, so then I'm gonna end at 1.017 as my growth factor. So now P is equal to P sub 0, original population, my growth factor to the power C. Alright, so if T is the number of years since 1990, right, so we have the point 03.7 as data point. So P is equal to 3.7, 1.017 to the power T, where T is 0 in 1990. So answer for A. B. What will be the population in 2005? 1990 to 2005, T is 15. So P is equal to 3.7, 1.017 to the power 15. And that is approximately 4.76 million. C. Estimate the doubling time. Doubling time will be 2 times 3.7 is 3.7 times 2 is 7.4. So doubling population original growth rate to the power T. And now that you learned section 2.6 logs, I'm going to solve this for first algebraically. Is equal to 1.017 to the power T. From here, log of 7.4, 3.7 is equal to T log of 1.017. And so T is here is equal to log 1.017 divided by log 7.4 over 3.7. And this will be approximately 41 years. So the population will double approximately 41 years. Now let's do that with exponential formula. I'm gonna move this here. So first equation is 3.7 1.017 close the parentheses to the power x. My second equation is 7.4, and then so we have, let's have the windows from 0 to x is my time. We found it 41, so let's go to, let's say, 60 every one, and then population from 0 to let's say 10. If the doubling is 7.4, I'm going to go above a little bit and then graph. Okay, let's quit. Okay, after it gave me an error, I went to second stat plot and made sure it's off by turning it off. It was on, so then I went to the right and enter off. Then went back to my Y's and graph. Alright, so now I'm going to find second calc, the intersection point. First curve, second curve, and then guess. 41.1 approximately years. So we end up finding the same answer here. Next question, problem 10. The 1995 population of France was 58.1 million, with an growing at an annual rate of 0.3%. Alright, 0.3% without the percentage symbol is 0.003. You divide by 100. This is your rate. To find a factor, I'm going to add 1. So 1.003 is your growth factor. The first question is find an expression for the population at any time t. Find a model. So population, p sub 0, growth factor to the power t. So population is then 58.1 million is the original, and then my growth factor to the power t is the answer for A. What will be the population if in 2010? 2010 time is from 1995 to 2010, 15 years passed. So population is then 58.1, 1.003 to the power 15. This should give you approximately 60.8 million. To answer C, a population time, like the doubling time, will be, I'm going to multiply 58.1 by 2. 116.2 is equal to 58.1, 1.003 t. So solving algebraically, 116.2 over 58.1 is 1.003 to the power t. Algebraically, I'm going to take log of both sides, log 1.003 to the power t. Exponents become your coefficients, so this is t log 1.003. So now I'm going to find t is equal to then log 116.2 58.1 divided by log 1.003. You should be able to find approximately 231.4 years. So the population of France will double about every 231 years. Population will double every 231 years. Let's look at our graphing calculator. Going to clear, wise, clear, and clear. Okay, now let's say I'm gonna type my function here, 58.1, 50, clear, I'm gonna go up, 58.1, parentheses, 1.003 to the power x. And on the x, let's go from 0 to 250. Let's say every 10. On the y, let's go from 0 to 30. Every 1. Let's graph. Alright, so with y, I type my function, and then on the window x, I went from 0 to 20, increments of 1, and then the y min, because this is your original 58. I started from 45 to 100, and then when I graphed it, this is what I obtained, and then if you want to find this specific value, and then you can say second calc value 1. So my time is 15, and enter 60.77, which is 60.8 here. So if I wanted to find answer C, then I would have 58 point, and then y2 is 116.2, and on the window X, I would go with my window, I go with 0 to 300 with increments of 10. You can choose different increments. Y min is 45. Because original is 58, I took a number less than 58. And the Y max, I went up to 150 because doubling population is 116, so I picked a number greater than 116 and increments of 10, and I graphed it. And then now I want to find second calc intersection 5, enter, first curve, and then second curve, and then enter. 231 years, that's the answer we found here, approximately to 231.4. Alright, last question from this section is problem 16. In 1998, the population was 268.2 million. So let's say population of United States, USA, is 268.2, and then the growth rate is 0.7%. 0.7% is 0.007. Add 1.007 to the power t, and the population of Mexico is 100.1. With a growth rate of 2.2%, 1.022 to the power t, and so t is 0 in 1998. That's your starting year. If these growth rates continue, use either graphical or numerical methods to estimate when the population of Mexico will overtake that of the United States. So if I want to find it numerically, I'm going to make both functions equal to each other. So 268.2 over 100.1 is equal to 1.022 to the power t over 1.007 to the power t, and I can write this as 268.2 1.022 over 1.007 t. Then I'm going to take log of both sides, and then log of, and then the t becomes the coefficient, and then t is equal to log of 268.2 over 100.1 divided by log of 7, and the answer will be approximately 67. And then so 1998 plus 67 is 2065. Let's do the graphical approach. Going to clear, and Y's I'm going to clear and then clear. Now I'm going to both functions. Let's go up 268.2, 1.007 exponent x, 100.1, 1.022 exponent x. And my window on the t, I'm going to go from 0 to 100, and then on the population I'm going to go from 50 to greater than 268, let's say 300. And then let's graph and see what happens. So looks like I need to extend the y a little bit. So y, I'm gonna go from, let's make it 500. Now they intersected, and alright, the line at the bottom, the equation, the exponential function at the bottom is for Mexico. The starting is 100, right? The starting is 100. And then above, exponential function is for USA. So the intersection is, let's find the intersection, second calc, 5, enter, second one, enter, and then guess. I think it freeze. I'm gonna redo it really quick. And when I applied the same method, I found intersection 66.7 like we did find before. And let's close the view. Alright, I can do it again. Second calc 5, and I want on the first curve, second curve, and then guess. Intersection. Time is 67. Population is 427 million approximately. And when it overtakes, you know, the bottom function is for Mexico. When the population overtakes is after t is 67, about 2065. So the population of Mexico will overtake that of the United States in about 2065. Hope this helps. I'll see you next video. Thank you.